Hi, everyone. Welcome to Math Moment with Mr. Dustin. I am Mr. Dustin. This is the second of 10 episodes for this summer, and today we are covering fractions and decimals. And so this is a concept that is useful for anybody in 6th through 12th grade, although today's particular episode may be more useful for that younger side of that demographic, just because it is a basic introduction of what fractions and decimals are. And just a couple reminders before we get into it. The summer reading program is in full swing now, so feel free to register via Beanstack. I have a tutorial on that in my previous video that'll also be up at this time. And so feel free to check that out if you have any questions about registering or anything like that. So without further ado, let's get into it. What is a fraction? A fraction is a numerical quantity that is not a whole number. So this definition shows us that a fraction is a number, and now we need to define what whole numbers are. And so whole numbers are basically, a lot of things that we're familiar with. There's 2, 77, 849, 450, 742. Basically, just like any of the numbers that you're used to counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that kind of thing. Fractions are going to be numbers that come between these whole numbers. So for example, between 0 and 1, we have 1/2. Some of you may recognize that as 0.5 or 50%, that kind of thing. We'll go over the decimal form of these later, but we want to clarify some parts of the fractions. So we have what is called the numerator, and that is this top section of the fraction here. So in these three fractions at the bottom, we have 1, 3, and 4. These are all what we call the numerator. And then the bottom part is what we call the denominator. Now, I wouldn't introduce these unless I had a plan to use this terminology later on. So in next episodes, it's going to be important to know the distinction between numerator and denominator, and I'll clarify as we go along in those. Now, let's try to put some fractions on a number line, because that might help us visualize more, what these look like. So we have 0 and 1 as the two ends of our number line. So what I'm going to do is I'm going to count up the spaces between them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces here. And I'd consider the 1 to be like the 10th space. So to me, the most logical way to divide up this number line based on the spaces we have are in tenths. And so what that means is I'll have a fraction with 10 as my denominator, and then, some numerator, we'll call that x up there. So what I can do is I can say, oh, look, this first one, that's 1/10. Second part, 2/10. And I can go all the way down and just keep going like that. So I will cut back when I have filled in all of these fractions. So as we can see, I have 10 spaces with 10 fractions here. The last one is 10/10. Now, an important thing to note about fractions is that you can actually divide the numerator and denominator and get a number out of it. Well, obviously, like we say these are numbers, but a number that you might be more familiar with. So let's use 10/10, for example. So I want to say, hey, what's 10 divided by 10? Well, if you might remember, anything divided by itself is actually equal to 1. So labeling this part as 10/10, or 10/10 rather, is like equivalent to labeling it as 1. Now there are other equivalent fractions we can put in the middle here. So for example, 5/10, that's halfway there, so I can label that as 1/2. Or 2/10, that's a fifth of the way there, so I can label that as 1/5. As far as these lines go, I think these are pretty much the only ones I can do. Yeah, because then there's like 2/5, and it's not quite as exciting as before because we're working with similar denominators. So that's kind of the general idea with how they appear on a number line. You're kind of divvying it up into, equal portions. And even in between these, there are more fractions you can have. So I could put one in the middle right here and call that 1/4. That's a quarter of the way over there. Same with right here, I could call that 3/4. So there are infinitely many ways we can do this. This is just to kind of establish that, yes, these are numbers, and I kind of wanted to show the division aspect of it as well. Now, let's kind of take a step back and label some fractions within the drawings, because it's important to see how the numerator and denominator work to like label a situation like this. So let's look at this first circle here. We have 1, 2, 3, 4, 5 sections. And how many of these sections are blue? Well, we have 1, 2, 3 of them. So how this is set up in a fraction then is we'll have 5 as the denominator, because that is the total amount of spaces we have, and then the 3 will be the numerator because it is the amount of blue spaces that exist. So what this means practically is that we're saying 3 out of the 5 spaces are shaded blue. And so we could also use the fraction for the white spaces. We could say 2 out of the 5 spaces are white. And so if we were to add these together, then that would get us 5 out of 5, which is all of the spaces. That's a whole number. So let's try the same method on these other shapes. So we have a square here. That would be this one. And how many spaces are there? There's 1, 2, 3, 4, 5, 6, 7, 8 spaces. And how many of them are shaded blue? Well, we have 1, 2, 3 of them. So now fraction is going to be 3/8. And that's, in a practical sense, that tells us that 3/8 of the spaces are shaded blue. Now let's go to the bottom left here. We have another square. This time there are only 4 spaces, and 3 of those are shaded blue. I don't know what this drawing's fascination with 3 as the numerator is, but I think that's going to change in a moment. Now, if we have the square in the middle here, we have 1, 2, 3, 4, 5 spaces, but this time only 2 are shaded blue. Yay, we get something other than 3 as the numerator. There we go. And then for the last one, we know it's the same kind of shape as the one above here. So that's 8 spaces total. This time only 4 are shaded blue. So I guess it's 4 out of 8. Now, something I want to show you is equivalence in between fractions. So I'm going to give you 3 fractions that show the purple spaces shaded. Let's see, 4 out of 6, and then 8/12. Now, these are all signifying that 2/3 of the entire circle is shaded as this purple color. So how does that happen? Well, this is something that we call reducing. We can get from this 8/12 to 2/3 by a method of reducing, and I will go over that in the next video. But I wanted to show that, yes, you can have fractions that are equal to each other. So just like that. And we also can see that a bigger denominator does not mean that the fraction itself is larger, because 8/12 is the same as 2/3. You can see from the picture that the same amount of space is actually shaded here in the circle. You have this line down and then out to the side, and then a line down and out to the side. So we just need, the main thing is keeping track of the numerator as well as the denominator. So you want to get as close to the same thing as possible. So like the closer the numerator and the denominator are, the bigger your fraction is. But in another sense, you'll also have fractions that are larger than 1. But for today's purposes, we're only going to go up to fractions that are 1. So with that, we're going to go into a break. And this drawing here is just a representation of one whole and then different ways to break it up. So kind of what I did with that number line, but in a like more colorful and kind of a cool way. So after the break, we'll go on to decimals. Hi, everyone. Welcome back. I hope you enjoyed the break. So let's move on to decimals. So what is a decimal? Well, a decimal is a fraction whose denominator is a power of 10 and whose numerator is expressed by the figures placed to the right of the decimal point. Now, that is a confusing definition, and so let me kind of demonstrate what this definition is telling us. So a power of 10 is going to be something like 10 or 100 or 1,000. So these are what are called powers of 10. And I'm not going to go into too much detail about it. That's for a future time. But basically, you can see, you add zeros to the end of it, and that's kind of like a power of 10. And so we also want to see that the numerator is what is to the right of the decimal point. So let's look at these decimals over here. We have 0.5. So that tells us that 5 is the numerator. That is a really bad 5. 1 second. 5 is the numerator. And now what to choose as the denominator? Well, basically, we look at the number of decimal places, and that's going to tell us how many zeros there are. And so what I mean by a decimal place is, you see this decimal point? Well, go to the right, and that's how many spaces we have. So this shows us 1 space. 1 space, 1 0. So 5/10, and that's the same as 0.5. Now, let's look at 0.25 up here. So we know that 25 is the numerator because that's what's to the right of the decimal point. And then the denominator, we're going based on the number of decimal places there are. So I see 1, 2. And that gets us 100 at the bottom here. So 25 100ths. So we can see that these are equivalent. And that's kind of what this definition is saying as far as, the fraction in relation to the decimal. And most of the time, you'll get something that's reduced instead of what we wrote here. And since I haven't gone over reducing yet, I'm not going to get into it. We will tackle that in the next episode. And so the important thing to know is that these are connected and they are equivalent in a lot of cases. Equivalent meaning equal to each other. So decimals on a number line. Well, luckily for us, we have the same number line as before. There are 10 spaces, and so we know that 1 is right here. So this one is a little easier, I think, than the fractions, because I can just do 0.1, 0.2, all the way up to 1 again. And this time there's not a 0.100 because that doesn't really work well. Notice if I do 0.100, that's not really going to get me much of anything because these extra zeros don't count for anything after the decimal point. So instead, it's the same thing as 0.1. That's why we have to go to 1 after 0.9. And I'll cut to when I have this all filled in to kind of show the number line a little better. All right, so here's the finished number line, and we can kind of see, it rises up 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So as we get closer to 1, we'll start to get even like larger numbers here. So we'll have 0.95, for example, and that's going to come in between 0.9 and 1. Now, just because it has 2 places does not mean it is any larger than anything that came before it. The reason it is larger is because it is 0.95, and that's greater than 0.90. That's essentially what we're saying. And you'll notice there's kind of a correlation here. We have 90 and 95, which we know in whole numbers, though, that 95 is greater than 90. So it's kind of a similar principle. It is kind of an unspoken, there's a 0 after this. There are infinitely many zeros after all of these decimals. We just don't show them because they don't really change the outcome of what we're comparing here. We don't use them until they're really needed. So for example, if I were to put down, say, 0.15, well, now in your head, you kind of have to visualize, oh, okay, this is 0.15. So that's greater than 0.10, but less than 0.20. So like I said, there's kind of an unwritten 0 that, it means something, but we don't need to include it every single time. So in this case, it's just a matter of working with the decimals, and this is a brief introduction of them. Our focus is going to be on fractions later on. So it's pretty much all on that I have on decimals for now. So let's summarize what we have. A fraction is a numerical quantity that is not a whole number. A decimal is a fraction whose denominator is a power of 10, which we went over, and whose numerator is expressed by figures placed to the right of the decimal point, which we also went over a couple slides ago. And then both fractions and decimals are numbers, and that is important to remember because it's often easy enough to confuse it where you have, oh, yeah, this is 1 out of 2 or 1 over 2, which, yes, that's true, but it's also a number. We see that it's 0.5, and it comes between 0 and 1. So there's more to it than just 1 divided by 2 or 1 out of 2, although those are important meanings. And then the parts of a fraction, the numerator and denominator. The numerator is the top part, and the denominator is the bottom. And so that is pretty much all I have for today on fractions and decimals. In the next episode, we'll start adding fractions and subtracting fractions as well as reducing. And so that's a concept I brought up a lot, and we will get to it next time. So as far as today goes, the important points: fractions are numbers, decimals are numbers, and that's really the takeaway I want to convey. So there is a quiz available, and the link is in the description below the video here, and the link to this Jamboard is also going to be there. So if you would like to reference that as well, and please check out our future videos, yes, but also the first episode if you haven't already. Like I said, there's a helpful summer reading tutorial there for you if you would like to see that, as well as kind of an introduction to this program for this year. We also have many other programs that are coming up, and feel free to visit the library and inquire about those, as well as our website. So yeah, thank you for watching, and we'll see you next time.